Welcome back to your second lesson of Unit 4, or Unit 1, Chapter 4, quadratic equations. We have quite a few I can statements today. Today we're going to do a little bit more graphing and rewriting some equations from one form to another. Specifically, after this lesson, you should be able to, or you should be able to say I can, graph a quadratic function in vertex or intercept form. I have factored form in parentheses because that's what it is. It's a factored form of an equation. Sometimes I say factored form instead of intercept form, so I want that there so you know I mean intercept form if I accidentally say factored form. Be able to identify and label the vertex and axis of symmetry of a quadratic function. Be able to identify the x-intercepts of the quadratic function in intercept form. Transform a quadratic function from vertex and intercept form to standard form equation. And last one, use the properties of vertex and intercept forms to find values in real life situations. And this last one is one that may not be covered as much in the notes, but we explore tomorrow in class with problems and examples we go together individually or as a group. Please write these down. Like I said yesterday, this is what I want to see under section 4.2 notes. The I can or I will statements right there. So it's a guide for you and me, so we make sure we hit everything we need to through this lesson. So remember, the benefit of having this recorded is you can pause stuff and copy down equations, definitions, take as long as you need, or you may be somebody that writes really fast. So don't be afraid to hit the pause button on your calculator or on your computer. Go back, if you miss something, but I'm going to go through it maybe faster than some of you want, but that's a good thing is you can stop me. It's an individual teacher, so please take advantage of that. But the first one we're going to talk about today, and I'd like you to write down all this in your notes as well, as I know you would anyways without me asking. Vertex form, y equals a times x minus h squared plus k. Notice the x minus h is in parentheses. Well, vertex form. Why do you think this is called vertex form? It has something probably to do with the vertex, and you guys have got it. You're right. The vertex is h and k. Notice h and k, they come from the h and the k in the equation. So h, k, vertex, the maximum or minimum, that comes from the k value, not the h. So when we're looking at what is the maximum or minimum value, that's the k value. That's our max or our min. The axis of symmetry, x equals h. Same h as what's in the equation. Okay. A is the same thing as it is in standard form. So what is that? If a is positive, it opens straight up. If a is negative, it opens down. So this is vertex form. Benefit of this obviously is you get your vertex and axis symmetry without really having to do anything. You just look at the equation, identify what is h, identify what is k, and you graph it. It's as easy as that. So if we look at example 1, y equals negative x minus 3 squared plus 4. We see that there's a negative sign in front, so our graph should open up or down. It should open down, right? And we should be able to find the axis symmetry and vertex rather easily. So what helps me when I'm first learning these problems, or when I first learn these problems, is I would say identify what form are we in. If I see parentheses and something being squared with something added at the end, this is vertex form. So I'm going to write the general vertex form from above, y equals a times x minus h squared plus k, right above it. You may not need to do that. That may not help you, but this is something people that misidentify h, k, and a, it helps you narrow it in a little bit better if you write that right on top or bottom of it. So to find the vertex, we just need to identify what is h and what is k. In this problem, what is our h value? And be careful. Notice in the general equation, it's x minus h. So h is kind of the opposite of what the sign is in front of it. So x minus 3 makes h a positive 3. Okay, so you want to also think about h. What would make h? What would make x minus 3 be 0? If I put positive 3 in, 3 minus 3, that's 0. That means 3 is H. If I put a negative 3 in, that'll be negative 6. Won't work. K, more straightforward. K is what K is. Okay, if it's a positive 4 at the end, then K is positive 4. If it's a negative 4 at the end, if that were the case, K would be negative 4. But we have our vertex. Our vertex is 3, 4. Our axis of symmetry. Well, the equation for axis of symmetry is x equals h. Well, our h is still 3, so our axis of symmetry is x equals 3. So the cool thing with vertex form is h and k are right there for you. All you got to do is pick them out. Okay? So that's the vertex, that's the axis of symmetry. They want us to graph it. Here's the drawback to graphing it, in a sense, is there's no other nice point from the equation. So this is really the only drawback, which I think is a minor one. Seems how we have a graphing calculator that can assist us in getting more points. But I'm going to make a grid, just like you have to do if you don't have graph paper, which is fine. And notice that I try and make my intervals somewhat even. In this case, I'm going by ones. But if you don't want to go by ones, you don't have to. But you do have to label it so I know what your intervals are. Okay? And I can always expand this if I have to. It's not exact. It's a rough interpretation, a rough estimate. It's just to visualize it by hand. Okay? So don't worry about if it's not exact, if they're not exactly the same inches apart. As long as they're labeled, we'll assume that the intervals are equal. So I'm going to plot the point 3, 4. 1, 2, 3, up 1, 2, 3, 4. Label that. My axis of symmetry is the line that goes through the vertex. It's always a vertical line. And that's x equals 3. We know it opens down because a is negative. We just need to get some points on either side. Now, I could make my own xy table and put some values in. But why do that when we have a graphing calculator? Now, we've done that before. You've done that previously. Well, you know, we pick values on either side of 3 and maybe 0, maybe negative or positive 2. It's right next to 3, and then positive 4. See what we get. We can plug those in by hand and do that. We can also go to our graphing calculator and plug in the equation. So here's where we left off yesterday. Let's type in the equation negative parentheses, x minus 3 all squared plus 4. We graph it. We get to see a picture of it. We haven't made a picture yet, so nothing really to compare to. But if we go to the table, which you can always see the table here, but on your calculator you may not, we can see that at 3, 4, which luckily for us, we're already at 3, 4 in the middle. We have some values here on either side. So I just drag out my table and I say, okay, 3, 4 on either side. I'm going to pick one on either side. So I'm going to pick 2, 3 over 2 up 3. Let's use over 2 up 3. And then I'm going to pick 4, 3. Which I could reflect that over the axis of symmetry if I wanted to. If I want to plot other values, 1, 0. Those are going to be important later where the zeros are. Foreshadowing for tomorrow's lesson. I could graph all of them if I wanted to. I only need one on each side. I was just bragging a little bit, showing how we can get all those values from the table. Have now graphed it in vertex form. I've labeled the axis of symmetry, and I found the vertex. Okay. Real quick with this one, I want to use this problem because there's a little bit of a wrinkle to it. Y equals 1/2 times x plus 1 squared minus 2. And no, the wrinkle is not that there's a fraction. Okay? The wrinkle is the h and k identifying that. This is where many people make that mistake at the beginning. But usually by the end of the lesson or at the end of the unit, we get better at identifying h and k. So axis of symmetry and the vertex, let's do those two first. We know the axis of symmetry is what? Well, the axis symmetry is x equals h. What is our h value from this equation? If it helps, write the general equation in. Can you tell me what h is? If you're saying h is positive 1, you're incorrect. If you told me h is negative 1, you are 100% correct. Remember the trick I gave you before. Rewind it. I did say this. You want to make the x, in this case x plus 1 part equal 0. What makes that equal 0? If I plug in 1, it makes it a positive 2. 1 plus 1 is 2. If I plug in negative 1, negative 1 plus 1 is 0. So that's why it's negative 1. Or just think of it, the opposite of the sign inside the parentheses. If it's a plus sign, then the opposite of plus 1 is minus 1. If it was minus 1, the opposite of minus 1 is plus 1. So whatever works for you, but to check it, plug it back in. Does it make x plus h or x minus h equal 0? Whatever makes it equal 0, that's your winner. So that's our axis of symmetry. To get our vertex, we need both h and k. And this is why the trick to vertex form is correctly identifying what is h. Because if you get h wrong for the axis of symmetry, you're going to get h wrong for the vertex. Because they're the same value. So we identified h to be negative 1. So negative 1, our k. What is the k value? Did I trick you? Did you say positive 2? I hope not. Because k, remember, it is what it is. If it's a negative number, then it's a negative number. If it's positive, it's positive. So we found the axis of symmetry. We found the vertex. Boom, boom, boom. Pretty fast. So we're going to grab those values. Once again, make a grid. 1, 2, 3, 4, 5. I know this sounds probably loud, but I can't write lightly. It's going to make a noise no matter what. I've tried. So you just have to bear with it. Negative 1, negative 2 is right here. That's our vertex. Our axis of symmetry is x equals negative 1. I don't know why I like to use these red dots, but I do. There's our axis of symmetry. Now we need values on either side. We can make a table by hand, or we can just go to y equals and let the graphing calculator do it for us. So 1/2. If I want to put a fraction in, there's a cool way to do it. If you hit math y equals, alpha y equals, there's this window that pops up. First one is just a regular old fraction. That's what we want. So I'm just going to hit enter or use 1. And I'm going to put 1 over 2. 1/2. You could put 0.5. You could put 1 divided by 2 in parentheses. It would do the same thing. But that's just a cool fraction app. If you want to rewind that and try that on your own, if you have your own calculator at home, I strongly suggest it, because being able to use the fraction app on your calculator is going to make your life a lot easier as we go along, especially if you're someone that doesn't like fractions. So here it is. We said the x symmetry was at negative 1. Sure looks like that to me. In fact, I'm just going to slide this graph out here so we can compare it when we're done. But let's get some values from the table. We had second table. We said our middle point is negative 1, so let's go up to negative 1, put that in the middle. And look, it's even going by fractions on the y scale. That's pretty cool. So negative 1, negative 2, that was our vertex. We're going to pick some other points. I'm going to slide this table out so we can take a look at it. Pick some other points. You may not want to label the fractions, so you may just skip over that. So maybe you go to negative 3 and 0, and you go to 1 and 0, perfectly fine. If you feel daring and you want to estimate those fractions, remember negative 3/2 is negative 1.5. So negative 1.5, negative 2, negative 1.5 would be like right about here. So you can do that, okay? Positive, should be a positive 0.5, or negative, excuse me, 0, negative 1/2, that's what I meant. It's about right here. So it's not exact on my graph because my graph intervals are not exactly given, but it should be pretty close. And if we compare the graphing calculator graph to our graph, it looks like we did a good job. Okay, so that's graphing in vertex form. Okay, the last one we're going to learn about today is intercept form. Excuse me, lost my train of thought there for a second. Intercept form, y equals a times x minus p times x minus q. I call this factored form as well sometimes. Why? Because it's factored. It's two binomials with a monomial possibly in front of it. It's factored form. That's what it is to me. So sometimes I slip up and I say factored form. That's, to me, the same thing as intercept form. So please keep that in mind if I say that in class tomorrow and you say, Mr. Kuhn, it's intercept form. You're right. You can correct me on it, but I just slip up and say factored form, and you'll see why once we get to the factoring. So the x-intercepts are p and q. Once again, the opposites of what's in the parentheses. So when you see parentheses, and just like when we did with the finding the h value with the opposite for vertex form and intercept form, it's the opposite of p and the opposite of q. The axis of symmetry is x equals p plus q divided by 2. So it's a little cool formula, or it's the midpoint between p and q, if you think about it that way graphically. And we'll show you what I'm talking about here in a minute. Example 1, y equals negative 2 times x minus 1 times x minus 5. So you see it like this. It's two parentheses next to each other, not something being added. There's no squaring going on either parenthesis. That tells me that we are in intercept form or factored form. So remember, for a helping guide, it may help you, it may not. Above or below, we write in the general equation, which is y equals a times x minus p times x minus q. By looking at, and that's a q, not a 9, q. By looking at the a value, negative 2, does our graph open up or open down? Right, it should open down. A is negative, it opens down. So we should have a frown face for a graph when we're all done. So let's identify the axis of symmetry. The axis of symmetry can be found or identified by the following equation: p plus q divided by 2. We learned about that up there. This is the axis of symmetry. So what is p and what is q? Well, from this equation, we can see that p is 1, and we can see that q is 5. So 1 plus 5 divided by 2, that's 6 divided by 2, which is 3. So our axis of symmetry is x equals 3. So on the graph, 1, 2, 3, there's our axis of symmetry. So axis of symmetry, we also know that we need the vertex. The vertex. That is still going to go along. We know the x value is 3. It's just like when we did standard form yesterday. That's what I'm trying to say. When we did standard form yesterday, we had to find the y value. How do we find the y value once we found the x value yesterday? Well, if you remember from yesterday, hopefully you have it in your notes. You can pause it and go look it up if you don't want me to give you the answer. But what we did is we took that 3 value and we plugged it in for x. That's what we're going to do today. Everywhere we see an x from the general equation, we're going to plug that 3 value in. And we can use order of operations, we can put it in a calculator. These are smaller numbers, so I'm just going to simplify it by hand here. 3 minus 1 is 2. 3 minus negative 5 is negative 2. Negative 2 times 2 is negative 4. Negative 4 times negative 2 is positive 8. So y equals positive 8. So our vertex is 3, 8. So we can plot these points. I'll show you the cool thing about intercept form here. Once we get our axis of symmetry and vertex, which We have, let's see, I'm going to have to just go a little bit higher, I think. Okay, so here's an XY grid. We're going to plot the point 3, 8 over 3 up 8. 1, 2, 3, 4, 5, 6, 7, 8. It's right here. 3 to 8. That looks like more 4 to 8. Let me move that over a little bit. Sorry about that. And then our axis of symmetry goes right through the middle. So here we are, 3, 8, x equals 3. We know the graph opens down because a was negative. Here's the cool thing with intercept form. Excuse me, intercept form, or what I call factored form. Whatever P and Q are those are values where the graph touches the x-axis or the x-intercepts. So we identified P to be 1, and we identified Q to be 5. It makes it really easy for us. Put a dot at 5 on the x-axis, put a dot at 1 on the x-axis, and we have a graph. So the advantage of intercept form is it gives you two values on either side of the vertex. Now remember we said we had this big equation for the vertex, add P, add Q divided by 2. Well, that's really the midpoint. If you look at it, we count 2 points over to the, not necessarily vertex, but axis symmetry. We can count over, they're equidistant from that symmetry line. So that formula just follows with averaging the 2 points together to find the midpoint. It's the same idea when you did that last year in the 8th grade, or when you did in geometry last year. Hopefully you were in 8th grade last year in Algebra 2. You might be in the wrong spot if you were. So that is graphing it by hand. If we want to do this in the graphing calculators to see if you did everything correctly, I strongly advise doing so. Checking your work, even if you have to show your work by hand, the graphing calculator can let you know whether you got it right or wrong quite often. So I plug in x minus 5. I graph it. See if we get something that looks like what we had. I'm going to change my zoom window. If you do zoom standard or zoom 6, that gives us a more standard window. Like what we have, there we go. Now we're going up. My 1's all the way to 10. If I compare that graph to my graph, it looks very similar. If we want values to plot, if we need a table, I can still go to the table. I can still put, my vertex is at 3, 8, so I can put 3 in the middle, close to it, and I can get some XY values. Slide my table out. So I have technology to help check, and I can see that 1 and 0 is on my graph, 5 and 0 is on my graph. It all makes sense. It all gets the same answer, and that's why you check it. Because if you have more than one valid way to do something, both methods should give you the same result. If they don't, then you either made a mistake with one of the methods or a mistake overall. And so it lets you check your work to make sure you did things correctly. Okay, the last thing we're going to do with these lessons, we're going to skip that example for now. Last things we're going to do with this lesson is using FOIL. We're going to rewrite these equations from vertex form or intercept form into standard form. Remember, standard form, what is standard form? Y equals ax squared plus bx plus c. That is standard form. We're going to take our equations and we're going to make them look like that at the end. That's our goal. How are we going to do it? Well, FOIL, I'm going to show you another method, the table method for multiplying or the box method for multiplying. But you have to use a method. I'm going to show you both. You pick one and use it. Okay, if you like FOIL, great. If you don't and you find something else, I'm going to show you that as well. First of all, before we can use FOIL, we have to decide what does x minus 3 squared mean? Well, x minus 3 squared does not mean does not mean x squared minus 3 squared. I know some of you were thinking that, but that is not what it means. Okay? So let's just put that off to the side. That's not what we're doing. So if you think that's true, this is big no. No. Don't do that. So x minus 3 squared, if it doesn't mean x squared minus 3 squared, what does it mean? Well, what it means is x minus 3, and I'm going to make this in a different color. Let's try blue. What it means is x minus 3 times x minus 3. So before we can FOIL it or do anything, we have to know what x minus 3 squared is. It means multiply what's in parentheses by itself. And if it was x minus 3 to the third power, there'd be 3 x minus 3's in parentheses. If it was x minus 3 to the fourth power, there'd be 4 of them. We don't really want to FOIL all that, but we'll find out later in the year how you can multiply those out. There is a way, believe it or not. I'm sure you're all excited. So what do I do first? Where do I start? Well, I start with the x minus 3 times x minus 3. Because you could multiply by 4 if you wanted to for the first x minus 3, distribute it to x minus 3, and then FOIL it. But I like to get the FOILing done first. So there's 2 ways we can do it. We can FOIL it, or we can use a box. I'll show you FOIL because you probably are comfortable with FOIL, and remember FOIL. FOIL, the F stands for first. That's F. X times x, those are the first terms. X times x is x squared. Outer, the O, outer, outside terms, x and negative 3. Negative 3 times x is negative 3x. I stands for the inner terms. Negative 3 times x is negative 3x. And the last, that's L. Negative 3 times negative 3 is 9. So this is kind of all in parentheses. This minus 10 and the 4 in front. Before we can go further, we have to combine like terms. See how I line them up, the like terms, as I went? That was on purpose. Negative 3x and negative 3x does not make 0. It does, however, make negative 6x plus 9. Check in your calculator. Do negative 3 minus 3. You don't put the x in. Negative 3 minus 3, that'll give you negative 6 minus 10. So hopefully that's a reminder on FOIL. Finishing off this problem really fast. Percent 4x squared. Why did I put that x squared there? That was silly. Should be just a 4. So we have one more thing to multiply. We have one number or one term outside of the parentheses. What you do with that term is you distribute it, which just means I multiply it by each term inside the parentheses. 4x squared minus 24x plus 36. But still, that subtract 10 outside. So how come I don't multiply it by the negative 10? The negative 10 is not in parentheses. If it was in parentheses, then we would get multiplied by negative 10, but that's why it doesn't. So we say this is order of operations. Basically, we say we subtracting and adding for last. We can combine these like terms. 36 and negative 10 gives us 26. So that is the traditional FOIL method. Okay? So there are other methods we can use. And I'm going to show it to you. So that's FOIL. If you like foiling, use it. That's great. If you don't, here's a different way. And this way works pretty good with intercept form because there isn't as many terms there. So I think it might be easier to FOIL it or not. It doesn't matter. But the box method, I think, might be more helpful for this one, or just as helpful, I should say, as the last problem. It doesn't matter either way. It doesn't matter which way you use. You're going to get the same answer. So a good suggestion is when you learn both these methods, if you're comfortable with both, use both of them on a test or a project to double check your work to make sure things are right. That way, if you get the same answer for both methods, chances are you did something right or you screwed up twice. But we're going to go with you did something right if you get the same answer, hopefully. So what am I going to start with? The box method. The box method says take your binomials, x minus 7, x plus 6, and you put them on the outside of a box. And between each term, you put a dividing line. So between the x and the 6, I put a line between them. Between the x and the -7, I put a line between them. And what you do is you take each of the terms on the edge of the boxes and you multiply them together. So x times x is x squared. X times -7 is -7x. 6 times x is 6x. 6 times -7 is -42. You may have seen this method before. This may be brand new to you, but to me, it makes sure that I don't miss anything. Sometimes with FOIL, when I was in school, foiling something, I would miss a term. I'd go fast. Even though I knew what I was doing, I would miss terms. With this, it's impossible to miss a term because the box would be empty. Now, you may not multiply it correctly. You may say 6 times -7 is -1, and you accidentally add. I can't help that. You have to know that you're multiplying. Okay, but it should show you, shouldn't leave any terms empty. Okay, so you multiply them. So now we're done multiplying. I'm going to write out each row, kind of like we did with foiling last time. I'm going to line up the like terms. It looks exactly like what we did with foiling last time because we line up the terms and we see that the x terms are the ones in common in the middle. So I add those terms together. I do not multiply anymore. I add them together. -7 plus 6 is -1x minus 42. So are we done? No, we're not done because we forgot about this -3. Well, maybe you did forget about this -3. Some of you did. That -3 is really in front of x squared minus x minus 42. So what do we do when it's right next to the parentheses? We distribute. We distribute that term, which really means to multiply. So -3x squared plus 3x. -3 times -42 is positive 126. Check that in your calculator, make sure I was right. And here is our equation rewritten in standard form. Now, real fast, technology way to check your work, we didn't do it on the last one, but you can go back and do this if you have a graphing calculator, is you can graph both of these equations on the graphing calculator at the same time. And we'll see what happens. If I go to y equals and I type in negative, oops, let's clean this out, -3, I'll talk to a little bit easier, x minus 7 times x plus 6. And if I type in what we think the answer is, what should happen when we graph these? Think about that while I'm typing this in. What do you think should happen when we graph these? It shows that we are correct. Well, when we graph them, they should only show one graph, which is kind of hard because we're not scaled back far enough to see the vertex. But it looks like only one graph was displayed. How can we double check that? Go to the table, which you can see the table here. The y should be the same across from each individual x. And notice we have that. The y's line up. They are the same. So if you think today we did foiling or multiplying to check our work. If you want to check it this way, so I should say, whether it's foiling it or tomorrow when we learn factoring, graph both the starting equation and the ending equation. They should be the same graph, and they should have the same y outputs because they're equivalent equations. When you manipulate an equation and factor it or foil it, you're really having the same equation, the same value as what you started with. You're just writing it differently. Okay? So let's wrap this lesson up. Let's see, did we hit the targets we're looking for? Hopefully you are able to graph a quadratic function in vertex or intercept form. We covered a few problems with that. If you're still having problems, go back and look that over. I'll come with questions tomorrow. Be ready to practice tomorrow as well. We should be able to identify the vertex and axis symmetry of all the forms now, including standard form we learned yesterday, but now in addition to that vertex intercept form, we found the x-intercepts of a quadratic function intercept form. I showed you that. That's p and the q values. So when we have intercept form, it makes it real easy to find the x-intercepts. And we transform the vertex and intercept forms into standard form equation. We did not address in the notes tonight how to find, use the vertex intercept values in real life situations. We'll do that in class tomorrow. So come ready to pick up with that one tomorrow morning or afternoon. Have a good evening.